This is January 06, question 7 on resistor networks. Consider a DC circuit with a constant current. State what is meant by the term conservation of charge. Explain how it applies to the circuit. So, first of all, conservation of charge in a DC circuit with a constant current. What that means is that the current or charge flowing around the circuit is always the same, and you can't create it or lose any of it. So a good way of saying that is that no charge is lost or created. Neither of these things happen at any point in a DC circuit, because that's what the question asks us for. And then it says explain how it applies to the circuit. So what that means is at any junction the total charge or current, since current is directly proportional to charge, in is equal to the total charge or current out. So there would be 1 mark for each of those wee bits. So make sure it's very important to read the question and split it into, there's really 2 parts of the question. There's the first part and there's the second, and that's how your 2 marks is going to be divided up. Part B shows a number of resistors connected in series and parallel to a 12-volt battery of negligible resistance. Internal resistance. Each resistor is labelled with its resistance. Now, what happens there is, consider the current coming out of the battery. The current's going to come here and it's going to split. And it's going to either split down through the 6 or over through the 3, 5 and 4. And so those 2 bits there are in parallel with each other. So I'm going to redraw this down below, and this is the first bit of the circuit. And I'm going to just put it down like this. I'm starting off with my 6 ohm resistor there, and I know that I'm going to put them in a line, a 3, a 5 and a 4, and they're in parallel with the 6 ohm resistor. Okay, we're going to look at the next wee bit. Right, so those currents are going to have rejoined again here, and they're all going to, the whole current is going to go through that single 8 ohm resistor. So it's just sitting beside that wee parallel combination. So that's an 8 ohm resistor there. And when we get to this junction, then it's going to have a choice again. So it's going to split here, and it's going to rejoin up here again. And so we have another parallel bit of a circuit with a 10 ohm resistor on a single line, a single 10 ohm resistor in a line, and then a 6, 2 and 7 on a line in parallel with it. And so I'm just going to draw it here. There's my 10 ohm, and then down below I've got the 6, the 2 and the 7. And that whole thing just goes back to the battery. And it doesn't matter that we make that line far longer. We're just doing that really to understand what's going on in the circuit. So hopefully that makes life a wee bit easier for you. These are 6, 2 and 7. You can now see that this entire line, and I'm just going to draw it in red. So 4 and 3, 7 and 5, that's 12 ohms. And this one here, 6 and 2 and 7 is 8 and 7, which is 15. And for each one of those, I'm going to do the product over the sum to get the whole parallel bit. So this parallel bit here is 12 by 6 over 12 plus 6, which is 72 over 18, which gives you 4. This bit here is 10 by 15 over 10 plus 15, which is 150 over 25, which gives you 6. And then all we have to do is add our 4, our 8 and our 6. So the total resistance is 4 plus 8 plus 6, which gives you 18 ohms. Now, that isn't even the answer. The answer then is going to be the current, but life is much easier now. We know that the voltage of the battery was 12 volts. The resistance is 18, and therefore our answer is 0.67 amps. It says identify the resistor which is the largest potential difference across it and calculate it. So if we have a wee look back again here to see our circuit, or maybe if we have a wee look at this here, the resistor which is going to have the largest potential difference across it is going to be the one which has got the largest value. And you can see here this total resistance here was 4 ohms, and therefore the total resistance here is 4 ohms. Then the voltage here is not going to be as high as it is across the 8. This total resistance here was 6 ohms, and again it's not going to be as high as across the 8. So the answer there is it's the 8 ohm resistor on its own. So the resistor is the 8 ohm resistor, and the potential difference across it, we're just going to use V is equal to IR. We found I was 0.67 and R is 8, and therefore our answer, this is actually the 8 ohms in here, and our answer is going down here. So V is equal to 0.67 times 8, and that gives you 5.3 repeated. So I'm just putting a dot over the 3. Last part of the question, calculate the power dissipated in the 2 ohm resistor. So I'm going to use P is equal to I squared R. But first of all, I have to calculate the current in the 2 ohm resistor. The 2 ohm resistor is in that parallel part here. If you look at this in here, okay? So we have to calculate, we know there's 0.67 amps of current going in there, but we have to calculate, first of all, we calculate our total voltage here. Then we can find out the current along this line. And that's the current going through our 2 ohm resistor, sorry. So I'm going to find the current in this. I'm going to find the voltage across this part. We know it's got a total resistance of 6. So the voltage, first of all, across that part, total resistance of 6 V is equal to IR. So we know there's 0.67 amps of current going in there. The total resistance is 6, and that gives us 4.02 volts. So we now know the voltage across that line there is 4.02 volts. So we can now go ahead and calculate the current in that line, and then we can work out what's across the 2 ohm resistor. So the current in that line is going to be I is equal to V over R, 4.02. And the total resistance of this little bit here is 15. That gives us 0.268 amps. So that's the current which is flowing through our 2 ohm resistor. And then we're just going to use P is equal to I squared R. And that's 0.268 squared multiplied by 2. And that gives you 0.14 watts, 0.14 watts is your answer.